Hello everybody, this is EE542, LAB2. So the first step, we're gonna create a VPC and configure it. So first create a VPC, select VPC only and give a name, whatever, and set the IP version 4 CIDR block, set to 10.10.0.0/16, and then we can create it. After we create a VPC, we will need to create 4 subnets. Then go to the subnets here, and we create a subnet. We select the VPC that we just created. Here I will select the LAB2-new, and then subnet name like LAB2/-1 and set to 10.0.1.0/24, and then we can add another subnet, which is 10.0.2.0/24, and we can add the third and the fourth subnet, and then we can create it. Okay, the next step is create a internet gateway, and we want to create it. It will appear just when we finish the subnet. So, and when they open, we need to attach the VPC here. So attach the VPC we just created. Okay, and the next steps, we're going to change the route tables. First we should know what VPC we use. Here we use LAB2 new, so we edit this route, and we added 0.0.0/0, and this is the internet gateway, and we attach it to the VPC that we created just now. Okay, then we need to load elastic IP address for our virtual machine, and it is a quite simple step. Here elastic IPs, and we load elastic IP address. Then we can load it. So we finish set up our VPC. Then we need to create a virtual machines. We go to the instance here, and the first step, we need to create a VOI machine, and then we need to create 2 Ubuntu machines, first as a client and second as a server. Okay, so first step, we need to create a VIOS machine. Give it a name like VIOS, and then search it. VIOS. Yes, we can find the mirror image here. Yeah. Then we can select one. Finish select, and we should select instance type. Then we need to select a key pair. Then we need to set up the network settings. We need to first select the VPC. We will select the VPC that we just created, like LAB2-new. Then we need to select the subnet. we use the subnet 1 as one interface. Then we select we create a security group. We need to give the security group to all TCP, all UDP, and all ICMP, which help me to configure our network. Yeah, like this. Then we dash the advanced network configuration, and we want add another network interface, and we set it to the subnet 2. Okay, then we finish and we launch instance. Then we create this one, VIOS new. This is the virtual machine we just create. Okay, we finished created, so we can create the server and client just like the VIOS new. We make a server Ubuntu to set an example. Launch instance, like server, and then select a Ubuntu. Amazon machine image, then we select the instance type, then we add a pair, then we added the network VPC to new subnet. Server we can select to network subnet 1, and then we select the existing security group that we just create. Yeah. Then we add another network interface. One network interface is to connect the public internet, and another is connect the VIOS. Okay. Yep. So we launch instance. That is okay. So it's the same step to create a client virtual machines, but we need to change the subnet. Okay. Then we need to change the network interfaces. Why? Because we need to disable the source and dash check, that this can make the internal internet connect. Okay. So we can find the VIOS interface here, network interface here. Yeah. And this is their interface ID. And remember it, network interface. So we can search the interface. We just see it. We just saw like CO6. CO6. Oh, I'll find it. No problem. We can find the CO6. Yeah, it's here. And we need to change it. Yeah, we will disable this source and destination check. Yeah. Okay, the next step, we can turn up our virtual machine. Here they are all running, so I just need to use my desktop to connect them.
This is part 2. I remember with iPod. So first step we went iPod 3
Open the terminal. Okay. Open it up. We need to open 3. So one is for client, one is for server, and one is for the VIOS. Okay. First, we need to go to the folders that's downloads, because the key is in the downloads. Okay, SSH dash I like 442.
Now this is part 2 element with hyper. So first time we
Yeah. So this is connect to the VROS.
server side.
Oh. Oh. Okay. Now we need to find the server. Yeah. Server is here, and the IP address is here. Yeah, we'll connect to the server. And finally, the client. The client IP address is here. Okay. Yeah, here. So this is server, this is the client, and this is the VROS as the router. So we need to edit the server and client router tables to make it the package first from client to the router to the VROS router, and then finally send it to the client. Yeah. First, I can show the IP route, and this is the route we add. We can use this command. Let's show the interfaces of the VROS. So VIA10.0.966, and this is the interface IP address. And use DV X0. So this is the command. When we add it, we can then we need to add the route to the client, and this is the route I added. It's the same command, but change the part of this command, and then we can trace route. So we can see this is the one of the interface of this VROS router, and this is the final IP address. So we finally successful made the VROS as the router of the client server. This is the part 2, measurement with iPerf. This is the client and this is the server. First we need to install the iPerf package. Yes, we have already installed this package in my 2 virtual machine. Then we can exit the iPerf command. We need to start the server. first. And here, this is already in use, so we need to queue this server process.
Now let's go to
First, we need to find it. We need to queue it. Then we can start the server. Okay, the server is listening on the port number 5201. Okay, now we stop the perf in the client. -u-c server IP and the bandwidth we can set a low bandwidth now, 100 megabits.
As you can see, the bit rate is quite low.
So we can see the server received the packet with 0% loss, and then we will increase the
Here is the
max bandwidth on the client,
max throughput
1 G. So that we found the server can't receive the whole packet because the max throughput is not enough to support it, because this use a UDP protocol. So the client will send the packet without the wire limited, so it can send what datagrams that it wants. So with the limited of the wire, so the receiver server cannot receive all the datagrams, so it can be lost. So the max throughput the max throughput we can achieve is here. Okay, so then we set a delay to our device. We don't have ETH0, but we have ENX. This is the bundle version difference. Execute it, and we use the default bandwidth limitation to execute the command. Oh, sorry, it's wrong. And we use this to send the datagrams. Yeah, so that we can find the first in the first part of this transmit, we will lose the datagram because we set a delay on these datagrams. And then we set a other we set a other rule with the delay 0 and the loss 10%.
if you
Oh, another mistake. Change it. Okay, we set it, made it, so we can run it with the limited bandwidth 1000 megabits. Yes, we found it. There are nearly 10% datagram lost. So then we want to use the TCP to test. Set a 1 gigabyte. Use TCP protocol. Yes, we can find the difference because TCP is a reliable protocol, so there's no packet loss. This is the difference with the UDP. Okay. Yeah, that's all. Yeah, so there's a question. So why is it not allowed in AWS? This comment, because I think our instance is that has a limited the internet card. So that's maybe we will get an error. Yeah, that's all.